You're standing in the rain, 30,000 years ago, holding a wet stone axe. Your grip should be slipping. It isn't. The ridges on your fingertips are quietly doing something you will never notice and never thank them for. You press your thumb into the wet wooden handle, and it holds. Somewhere far in the future, a machine will scan these exact ridges to unlock a glowing glass rectangle. But right now in the cold, they are just skin. Skin with tiny hills and valleys carved into it before you were even born. You glance down at your hand, the same swirls your mother had, the same swirls no other human who has ever lived will ever share. And here is the strange part. You have absolutely no idea why they are there. So let's ask the obvious question. Why do you have fingerprints at all? You'd think the answer would be simple. Grip, right? They help you hold on to things. That's what everyone says. That's what your teacher told you. It feels completely true, but the honest answer is that scientists have argued about this for more than a century, and they still don't fully agree. These little ridges show up on every finger, every toe, and both of your palms. They form months before you are born. They stay with you, unchanged, for your entire life. They are so reliable that whole justice systems are built on top of them. And yet the most basic question of all, what are they actually for, has never had a clean, settled answer. A pattern that precise, that permanent, that universal. And nobody can quite explain why it exists. That should nag at you a little. It has been nagging at scientists for 150 years. Every person you have ever met walks around with the same unsolved riddle stamped onto their hands. Here's the thing nobody tells you about fingerprints. It's not one thing. It's never one thing. There are at least 3 serious theories for why they exist, and the most famous one is probably wrong. Along the way, there's a bit of Alan Turing, a Swiss woman stuck at an airport, and a koala that could, in theory, frame you for a crime. We're going to walk from the easy, tidy facts all the way out to the genuinely bizarre. Best part saved for the very end. Let's go. Let's start with what a fingerprint even is, because the word itself is a little misleading. You don't really have prints on your fingers. You have ridges, tiny raised lines of skin called friction ridges that loop and curl and swirl across your fingertips. The print is just the smudge they leave behind. The ridges are the real thing. And they aren't only on the surface, sitting there like a sticker. They're anchored deep into a lower layer of your skin called the dermis. That's why you can't just sand them off. Scrape the top layer raw, and the ridges grow right back in exactly the same pattern. Criminals have literally tried to burn their fingerprints away. It doesn't work. They come back. Running along the very top of every ridge is a neat row of microscopic sweat pores. That's a big part of why you leave a mark on everything you touch. Your fingers are, very gently, always a little bit damp. Now here's the fact that catches people off guard. You didn't grow these as a baby. You grew them before you were a baby. Friction ridges begin forming around week 10 of pregnancy, deep in the womb, and they are essentially locked in by around week 17. Picture a fetus the size of your palm, floating in the dark, quietly finishing the most unique feature it will ever own. By the time you are born, the work is done. The swirls will get larger as your hands grow, like ink drawn on a balloon that is slowly inflated. But the pattern itself never changes. Not when you're 5, not when you're 50, not when you're 95. The same ridges you had before your very first breath are the ones touching the screen in your hand right now. Think about that for a second. You have been carrying a finished signature you wrote before you were born. So how does a fetus draw something that intricate, with no artist, no pencil, and no plan? For decades, this was a genuine mystery. Then, in 2023, a team at the University of Edinburgh cracked a huge piece of it, and it turns out the whole thing runs on math. Their study was published in the journal Cell, led by a scientist named Dennis Hedden. And they found that fingerprints form using the exact same process that gives a leopard its spots and a zebra its stripes. It's called a Turing pattern, named after Alan Turing. Yes, that Alan Turing, the man who helped crack Nazi codes during the war. Shortly before he died, Turing described how simple chemical signals, just spreading out and pushing against one another, can generate complex, repeating patterns entirely on their own. No master blueprint needed. The pattern quietly builds itself out of nothing but chemistry and time. In your fingertips, 3 molecules do the actual work. 2 of them, called WNT and EDAR, tell the skin to raise up a ridge. The third, called BMP, tells it to stop. On, off, push, pull, rippling across the smooth surface of the growing finger. The ridges begin sprouting from a few separate starting points, and then they spread outward like ripples across a pond. And where those ripples collide, you get a loop, or a whirl, or an arch. That's not a metaphor. That's genuinely the same kind of equation behind a tiger's stripes, quietly running on your hand. And it explains something we are going to come straight back to. Because if your pattern depends on exactly where those ripples start, and precisely how they crash together, then even the tiniest difference in timing changes the whole picture, which, it turns out, matters enormously. Which brings us to the most famous fingerprint fact of all. No two are the same. Not yours and a stranger's on the other side of the planet. Not even yours and an identical twin's. And that twin part is the truly weird bit. Identical twins share the same DNA. Letter for letter for letter. If your genes alone decided your fingerprints, twins would match exactly. They don't. They are similar, sometimes eerily so, but never identical. So what makes the difference? The womb itself. The exact pressure of the amniotic fluid around each finger. The position of the tiny hand. The precise instant each ridge decides to start forming. All the little unrepeatable chaos of growing a body in the dark. Your genes set the overall style, but the fine details, quite literally the fine print, get written by pure chance. You are, in the most real sense possible, the only copy that will ever be made. Not before you, not after you, not anywhere in 8 billion living hands. Back in 1892, a British scientist named Francis Galton sat down and did the math. He estimated the odds of two people sharing the very same fingerprint at roughly 1 in 64 billion. He also sorted all human prints into 3 big families: arches, loops, and whorls, a system that police still use today. And in that very same year, on the far side of the world in Argentina, a bloody thumbprint left on a wooden door frame became the first fingerprint ever used to convict a murderer. Within just a few decades, police forces everywhere were pressing inky fingers onto little white cards. Not because a single one of them could explain why the ridges existed, but because they were so flawlessly, permanently unique that it simply did not matter. Your body had been leaving perfect identification everywhere you walked for hundreds of thousands of years, long before anyone thought to look down and read it. Now, before we argue about what they do, let's ask where they came from, because you did not invent fingerprints. You inherited them from a very long line of tree climbers. Friction ridges are basically a primate trademark. Monkeys have them. Chimps and gorillas have them. Some South American monkeys even carry ridges on the underside of their grabbing tails. And every one of those animals shares the same deep story. Ancestors who lived their entire lives up in the branches. When your survival depends on grabbing a limb 60 feet off the ground, the skin on your hands becomes life or death equipment. The leading evolutionary idea is that ridges first appeared to help those ancestors grip and handle branches and food high up in the canopy. Then, tens of millions of years later, one strange branch of ape climbed down, stood up straight, and started using those same gripping hands to chip stone tools, nap flint, and eventually swipe at a phone. You never needed to grow fingerprints from scratch. You were handed them, preloaded, by animals who needed them just to avoid falling out of a tree. Which is a lovely, tidy origin story. There is just one problem. When scientists finally tested whether the ridges actually improve grip, the results got very weird. Because everybody knows fingerprints are for grip. The ridges add friction, just like the tread on a car tire, so things don't slide out of your hand. It's clean. It's intuitive. It was the textbook answer for a very long time. Then, in 2009, a scientist at the University of Manchester named Roland Enos decided to stop assuming and actually test it. He and a student dragged sheets of smooth acrylic across human fingertips and measured the friction directly, at different pressures. And the result was the exact opposite of what everyone expected. The fingerprints didn't boost grip. They reduced it. Here's why. Your fingertip skin actually behaves a lot like rubber. The more of it that presses flat against a smooth surface, the better it sticks. But ridges, by their very design, only touch at their peaks. The little valleys in between touch nothing at all. Enos measured that the ridges cut the real contact area by up to a third. So on a smooth surface, flat skin would actually grip better than ridged skin. Read that one more time. The single most popular explanation for fingerprints, the answer you have heard your entire life, may simply be wrong. Now, to be fair, Enos never said the ridges are useless. He suggested they might help grip rough surfaces like tree bark, or let your skin stretch without tearing, or drain water away from the contact point. But the simple, comforting tire tread story? On smooth glass, the bald tire wins. So if it isn't really about grip, then what on earth are they for? Here's the theory a lot of scientists now believe is closest to the truth. Your fingerprints aren't mainly about holding on, they're about feeling. In that same year, 2009, a French research team in Paris, led by a physicist named Georges de Berger, built themselves a fake fingertip. A little sensor covered in ridges, spaced just like the ones on real human skin, about 0.5 millimeter apart. Then they slid it across textured surfaces and carefully measured how it vibrated. And they found something genuinely beautiful. When your finger slides across any surface, the ridges convert tiny textures into vibrations. And because of how they are spaced, they tune those vibrations to one very specific frequency, right around 250 times every second. Now, why should that particular number matter? Because buried just under your fingertip are special nerve endings called Pacinian corpuscles. And it turns out they are most sensitive to vibrations at, you guessed it, roughly 250 times per second. So the ridges aren't gripping the world, they're playing it. Like the needle on a vinyl record, they turn texture into a signal that your nerves are perfectly tuned to hear. This lets you feel detail far, far finer than your nerves could ever manage on their own. It is the reason you can feel a single grain of sand on an otherwise smooth tabletop. Or tell silk from satin with your eyes shut. So maybe your fingerprints are less like tire tread and much more like the grooves on a record, and your brain is the one leaning in to listen. Suddenly a lot of things line up. Why our fingertips are so absurdly, ridiculously sensitive. Why the ridges sit exactly where we touch, poke, and explore the world. Grip was never really the main event. Sensation was. The most important thing your fingertips do, it turns out, is listen. But let's give grip one last chance, because there is one version of the grip story that genuinely survives. Have you ever noticed that after a long bath, your fingertips go all wrinkly and pruned? You probably assumed your skin was just passively soaking up water, like a sponge left in the sink. It isn't. That wrinkling is active. Your nervous system does it deliberately, on purpose. When your fingers stay wet for a while, your body fires off a signal that shrinks the blood vessels underneath, and the skin puckers up into those familiar little wrinkles. Which raises a fantastic question. Why would evolution ever build a feature that only appears when you happen to be wet? In 2013, researchers at Newcastle University put it to the test. They had people pick up wet marbles and slippery objects, first with normal fingers, then with wrinkled ones. The wrinkled fingers won, clearly. People handled the wet objects about 12% faster when their fingertips were pruned. On dry objects, there was no difference whatsoever. The wrinkles, it turns out, are rain tread. The channels let water squeeze out from under your fingertip, exactly like the grooves in a car tire pushing rain off the road, so you keep your grip on a wet branch or a slick, mossy stone. So picture your ancestor again, out in that cold rain, gripping the wet axe. Fingerprints for feeling the world. Wet wrinkles for holding on to it. Two completely different systems on the very same hand, quietly solving two completely different problems. Your fingertips might just be some of the most over-engineered real estate on your entire body. And believe me, we are not done yet. Now let's be honest about the messy parts, because there are a few. First, notice what we just did. We walked through 3 different theories: grip, feeling, and wet grip, and they can't all be the single headline reason. The truth is that scientists still argue about which one matters most, and the honest answer is probably that fingerprints do several of these jobs at once, all a bit imperfectly. Biology rarely hands you one clean purpose. Second, remember that koala I promised you. It is completely real. In the 1990s, an anatomist named Maciej Henneberg found that koala fingerprints are so close to human ones that even under a microscope, an expert can struggle to tell them apart. Koalas and humans last shared an ancestor over 100 million years ago, so this is pure coincidence of engineering, two totally separate species stumbling onto the identical solution. But before you panic, no. There is no documented case of a koala actually fooling a real crime scene. That part is a myth. Delightful, endlessly repeated, and completely unproven. I just wanted you to hear it from me before the internet got to you first. Nature reused a good design twice and handed us a mystery and a great party fact. There's one last thing I saved for the end, and it really is the wildest part. We have spent this whole time quietly assuming that everyone has fingerprints. Almost everyone does, but not quite everyone. There is an extraordinarily rare genetic condition, so rare that only a handful of families on the entire planet are known to carry it, in which a person is simply born with no fingerprints at all. None. Their fingertips are completely smooth, blank, like the rounded tip of a balloon. The condition has a wonderfully bureaucratic nickname. Doctors call it immigration delay disease. And there is a very good reason for that name. In 2007, a Swiss woman tried to enter the United States and got stuck at the border because the officials could not scan the fingerprints she had never had. A dermatologist named Peter Eaton looked into her family and found several relatives, spread across generations, all with perfectly smooth fingertips. The cause turned out to be a single tiny change in one gene, called SMARCAD1. And here is the quiet, astonishing part. Apart from missing fingerprints and having slightly fewer sweat glands on their hands, these people are completely, perfectly healthy. Which means the great unanswered question underneath this whole video suddenly gets very sharp. If you can live a full, normal, healthy life with fingertips as smooth as glass, then what, exactly, are the rest of us carrying them for? 150 years of science, and the smoothest fingertips on Earth just shrugged. So look down at your own hand for a second. Really look at it. Those swirls were finished before you took your first breath, drawn by the same math as a tiger's stripes, and no two of them alike in the entire history of the species. They might be for feeling silk, they might be for gripping wet stone, they might be for something we haven't even figured out yet. Every human who ever lived carried this same quiet mystery on the tips of their fingers, from the one gripping a wet axe in the rain to the one holding a glowing phone tonight. You press your thumb to the screen, and it unlocks. And for one small second, you know something almost nobody ever stops to notice. You are holding a question no one has fully answered, and you have had the answer written on your hands the whole time.